Yeah, hello, you're welcome. So, I know we started a bit late today, some due to some unforeseen circumstances, but then you have the video, you can always follow along. So, today is we are going to part 1B of our Sagemaker Saturday. So, remember the last 4 weeks we completed part 1A, which was doing the regression model with XGBoost, building it from web scraping to exploratory data analysis to feature engineering to deploying on SageMaker. And then today we are going to start the second part, which is now a classification model predicting churn for a telecom company. And we are going to use the inbuilt algorithm linear learner. So today we hope to cover up the exploratory data analysis and the feature engineering. And then next week we come and then we cover up now, we do the deployment of the model so that we can move on to other models. So remember, part 1 we are mostly focused on the inbuilt algorithms, and then part 2 we'll be moving on to custom code and moving on to Dockers and all that. So I hope you are enjoying the series. So let me just go straight. So let's go out of here. Just go straight here. Okay. So actually today we are getting this data from here. So let me start up the SageMaker Studio Lab first. Then I'll be explaining to you where we are getting the data from. So let's start that. Let's get started with SageMaker Studio Lab. Remember, you can do this with Google Colab. You can do this with Google Colab, or you can do this with Try Jupyter. So you can still follow through, or even if you have your Anaconda, or you can still follow through. Okay, so let's go here. So I'm going to go back here. I'm going to sign in. I already have the SageMaker Studio Lab account. So if you don't, you could request for it. Now I've signed in. I start the runtime. So while it's running, this is the data set we are going to work with. So we are collecting this data set from BigML. I already downloaded it. So here we have the state, account length, area code, phone number, international plan. So this is for telephone company. So we are trying to predict the behavior, or with all this data set, how could we predict at the end if the customer did churn or did not churn. So from there we can build a model to help this company, telecom company, take care of the churn, because losing it costs 5 times more to recruit a new customer than to keep a new customer. So if you see here, we are going to open the project, and then now we're going to go in. Then this is the repository already that I started with the project. So we have the land price project, which we did last 4 weeks ago for part 1, and then now we have the telecom churn prediction, which we are going to try to do today, the EDA and the feature engineering part, so that next time we'll be left with deployment. So we are trying to do the EDA today because it costs a company more than 5 times to acquire new customers and to retain an existing one. So we are going to, this is where the data is coming from, which I've showed you here. So I already downloaded the data, and then we are going to go through. So let me go back to our SageMaker Studio Lab, open our project. And then once we are here now, we are going to copy this repository as usual, as we did in part 1. And in part 1, we were very detailed. Took a lot of time for web scraping, took a lot of time for exploratory data analysis, took a lot of time for feature engineering and deployment. So let's go back here. So I'm going to go into this folder I just created, still empty, telecom churn prediction. And then I'm going to go to Git, clone Git. So I need the link of that repository. So let's go back here and look for the code. Let's go back, get the code from here, copy the code, and then take it now back here and paste it here. So I'm going to paste that, and then I clone it. So now I'll be copying all that we have on the GitHub. Remember, I'm going to leave the GitHub in the link. So it's saying no conda environment file found. Okay, no problem. Let's go here. So this is what we've copied. Remember, these are the 2 files I want to work on. Let me pull it a bit like this. So this is the file from this website. Yeah, this website. So this is the file already. So if you see here again, remember the state, the length of the account, the area code, international plan, whether the person is on an international plan or not, yes or no. If the person has subscribed to a voicemail plan, the number of messages the person, voice messages the person has received, total day minutes, total day calls, so all of that, you see. At the end of the day, we are able to churn. False means the person did not churn, true means the person churned. So this is the data, and then now we are trying to find patterns in this data to be able to predict this dependent column of churn. Is it with all these characteristics, does the person have a high probability to churn true, or with all these characteristics does the person have lower probability to churn? So that's what we are trying to do here. So you see, brought in the data. So if we go to the exploratory data analysis file here, so I can still close this one, no problem. So I'm going to select now the kernel. I need default Python, and then I click on select, and then this is our exploratory data analysis. So the bit of it, we are the problems, brief of the problem statement. Telecom companies spend huge amounts on energy to recruit new subscribers. So letting them go is not a good thing, not a good option. So building a model like this for a telecom company would help you to be able to keep those customers. So here, this is the steps for the exploratory data analysis. Remember, in part 1 we went into really much detail. So if you really want to look at it, you can also go back to part 1. But then let's walk along together. I'll leave the code, the link. You can copy it, and then you can also try this out on your own. So we are going to import the necessary libraries as usual, our NumPy, Pandas, Matplotlib, Seaborn. Then we are going to try to get a big picture, try to see what we have at hand, what are the number of rows, what are the number of columns, how many unique values per column, things like that, just to have a big picture of what we have at hand, because this is the very important step as a data analyst or data scientist or machine learning engineer, just to try to understand your data. So it helps you to know, you become one with your data, so that in future you anticipate what you have to do. Since machine learning, data science, they are some form of art, and you're making a lot of decisions in between. It's not really like clear cut. So you just need to know what you have at hand. So you get the big picture, you inspect the missing values. So we our machine learning models don't like missing values. They don't know what to do with missing values. So we need to check if we have lots of missing values. Then we start anticipating what to do with them. Because remember, the whole objective of exploratory data analysis is just to explore without necessarily changing the data. Just to explore. Then later now you can come back and for the feature engineering change things that you've seen. So we inspect the dependent variable, which is now the churn. We try to see, is it a balanced or unbalanced data set, and you're going to notice that it is an unbalanced data set. Remember, unbalanced is when you have one of the categories really low in terms of percentage. So that is a problem in machine learning. Now we are also going to inspect. Sorry, I have to correct this to inspect the numeric variables. So the numeric variables will be inspected, and then after that we are also going to look at the outliers, and then we are also going to find other relationships. So let's move on then. So here you see we are importing the libraries, packages. We're importing this. So we have our NumPy, Pandas as usual, Matplotlib for plotting, the Seaborn for visualization, these two, and then Pandas is the whole data set and data frame, data spreadsheet thing, data frame manipulation. NumPy helps with computation at the back. So this also is just to set the width so that we can be able to see the columns. That's what we are doing here, display the maximum columns. And then also this is to prevent Python and especially Pandas from giving us some warnings, especially when we try to slice part of the data and use. So it's going to warn us. So but then we know what we are doing, so we don't need these warnings. So we can just mute them by these two lines. So with this, you're ready to go. So now let's run it. Run that. So the next thing now is let us import the data set. So that's why we are doing pandas pd.read CSV. So we are trying to bring in this CSV file. This is the CSV file we are trying to bring in here. So and then we do a dot head just to see the first five elements. So when we run that, see this is what we have, which is what we saw when we clicked here. So we state, account length, area code, international plan, yes or no, and then at the end again, churn whether false or true, just like we saw. And then now we come down here, we look at try to get a big picture. So remember, the first thing we are trying to do here, this line, is that we are trying to create a copy of the data set, because in exploratory data analysis, you don't want to change the original data set. So if you understand the data, this is because we want to do a separate copy of this data set, so that they don't have the same IDs. So the one will not be affecting this one. If we don't use this dot copy, whenever you change this data, anything you do here is going to affect the original data set, which is what we don't want. So we do that. We know we are just exploring. Look, but don't touch. So dot shape, we want to get the shape of the data. So we have this 3,333 rows and 20 columns. Okay, not bad. Data.info. So we want to get just to see, okay, we have the state, and then it is not, there's the count of missing values, there's none really. Then it's an object, so it's seen this as a categorical variable. That's an integer. It's seen account length as a numeric variable. So we just want to see generally what is there. I can look at the size of the data. Okay, now let's move on then. So we can also go to data.end unique. So we are trying to see each column, how many unique elements are there. So we have 51 states, 212 accounts, 3 area codes, 2 international plan, yes or no, which we saw, and then also at the end here, the churn, yes, false, true or false, which is also what we saw here. So let's move on then. We are exploring, remember. So do the dot describe. This takes only just the numeric and variables, these ones, the ones with the int, the float. It doesn't take these ones, this object, because you can't really get the 75 quartile percentile or the median, all those things that you have down here. So when you run this now, you can also take a look. You'll see maybe account length, the average is 101, number of voice messages, average is 8, is the minimum, the median is 0. So you can just look at this and you see your total evening minutes, total evening calls, you get that there. So let's move on then. Now next thing is to inspect the missing values. So we want to say, what are the missing values we have here? Are there any? So you run this code. Remember, you run this code, is always going to help you all your data sets. So data, you check is it null and any of them. So when you run that, you see you have that. So you could have also done maybe .sum if you're more comfortable with that. So if we run .sum, you see we check all as 0, so there is no missing value. So let's just put .any there, and then we move on. So we see there that we notice that there are no missing values. Okay, that's very good news, that you see it's clean data compared to the data set we had last part 1a, where we had to scrape data from the website, the e-commerce website, to predict the price of land. It was really very dirty, real world data, really messy. But then this one is so clean. Okay, so always try to work with clean and real data so that you get the flexibility. So let's move on then. Now I want to inspect the dependent variable to see what are we, who came for the party for churn. So let's look at churn and see what it looks like. So we just use this group by dot size. You know this command is always going to help you. So you get, these are the number of false, these are the number of true. So these are the people who churn. And then now we can also run do a plot, a box plot with our SNS. So let me go up here. So let's go back there. We do our, let's see, okay, we have our box plot. So you see here, we have it with our, here, these are the true, these are the false. Let's move on. Now let's try to calculate how much percentage of it is churn. So you see 14.5%. So that's why even from this diagram you can see that it's an unbalanced data set. So you see here that this one is really short while that other one is really long. So we should know that we are going to need to deal with that situation in future. So this is an unbalanced data set, so we need to be careful when modeling. Okay, so now let's go ahead. We're expecting numeric variables. So we are trying to run this command. Remember, when you run this, you get data.dtypes, gives you all the data types. You already saw a similar thing in the data.info, but then you can just quickly see your data types here. And then now we're going to try to select just the numeric features. So remember, you have categorical features and numeric features. So we do this, run this command. We say data, select data type, which include equals to number. So we could have still used maybe float, select data type float, or select data type integer. It will still work out, but number just simply takes everything. So you have the account length, the area code. So you see all these are here. Remember state, which was let's go back up here. Remember state, which is not a number, is not included here when you do that. So let's go back down here. So we have now our numeric features like a subset of the data. So we can also take it now and then we try to get the discrete features. So we say here that we run this, say for feature. So we did a list comprehension. So feature in numerical features, if the length of the numerical feature, if the unique length is less than 20, so if it has less than 20 categories, like we saw when we did the n unique. So anything less than 20, let's see who are less than 20. Anything less than 20, like this one, for example, would be considered like can be considered like a discrete variable, because it can be that they just have 20 different possibilities or 20 different states of existence. So we have it here. So we have two. So if you see, we have the customer service calls and the area code. So those two have those two are numeric, but then they are discrete because they don't have infinite possibilities. So that's, we are trying to separate between continuous variables and discrete variables. So remember your statistics, you have to review that. So now we have this here. So let me run this code so that I'm sure that we are moving along together. So if there's anything to run down here, we can do it together. So we get that. Let me run this again. So if you see, we just print here just to see the head of the discrete feature. So we see that area code, everything, customer service, calls, good. So fine. Now, when we're exploring, so when you're exploring, you're just trying to see, just to be taking note of things. So now we're going to run this because we love to plot with SNS. So we want to be able to plot them side by side. So that is why this small function is here. So first, I'm trying to define the number of rows. So it's just one row. And then trying to say there will just be two columns, 1, 2. Now the figure size. Here, I think the figure size is too big. So maybe we could change it. Let's say we try something like let's just say 6 by 5. Let's try it. We'll run it and see. So I'm saying that for I in enumerate discrete features. So in this discrete feature, so enumerate, remember it takes this one and this one, it enumerates. Remember your enumerate, in Python, it goes like this, goes like this, goes like this. So for that, in that, now we're calling on matplotlib to help us to bring us the subplots templates, and then these are the number of rows which we passed here. These are the number of columns which we've passed here, and then now we are now determining the axis so that it is able to see from this. So it is looping on this I. So if I, for example, here you're getting 0 plus 1, so all of that now makes you to be able to say, okay, this one is going to be the first on the first row and the first column, while this one is going to be on the first row and the second column. So when you run this code, now you say plot it. So it's going to plot now x equals to I1. So here then now you're saying that hue is churn. So what you're trying to say here is that the churn should be what should be be like, it should break it down into churn. So break it up per churn status so that we can see the contribution of each. So when we run that, you get, oh, okay, it's even smaller now. So let's see if I can get that to maybe 8. Okay, that's great. Let me get that to 5, and then I get this one to 10. So at times just need to try and see how it looks like. Okay, it looks a bit better now. So let's go ahead then. So we can already see here that there are some area codes that, well, even though area codes might not be something we can really expect to predict on, but if we look at customer service, some patterns get interesting. You see here that when the customer starts calling here, maybe at the fourth call, so maybe the problem has not been resolved, you see that from the fit and the seat, the true, we have the highest possibility of churn, of having the churn. So this shows that it's a very important and interesting variable that we will need to consider in future, because here everything looks okay as it's the non-balanced data set. The churning, the true is lower than, by far lower than the false, by far lower than the false. Okay, by far lower than the false, as expected, by far lower than the false, as expected. But all of a sudden, from the fourth call, the customer is pissed off. So this would be a very interesting variable to look at. So we have an end-to-end to build. So let's move on. Now, creating the continuous features. So we separate now from our numerical features. If the feature is not in the discrete features that we saw above, that is not less than 22 elements, unique elements, then it is a continuous variable. So that is that. Now we go now here, we have 14 continuous variables. So to plot, since there are many, we could be plotting them one by one with our sns.hisplot1, sns.hisplot2, sns.hisplot3. So to make things go faster, we just do the same thing like we did there. Decide on the number of rows based on this 14 here, decide on the number of columns we want, and then we do the same. Fix size, enumerate just like above. The subplot takes the rows, the columns, and then also we are enumerating as we are moving ahead, and then we also plot the his plot, and we enumerating as we are moving ahead. We churn as the hue, always churn as the hue, since the categorical variable. So we can be looking here, we can see, okay, this looks like okay, it's below, maybe at this edge it's like that. You try to see, it seems like at this 0 here, we have there's many people on 0, and then there are people spread around the number of voicemails here, but then we see something here. We look at the total day minutes, we see, okay, maybe as the minutes are going higher, there's more churn. So we might need to do some diagnostic analysis to understand why, but for now, as exploratory data analysis, when you're doing exploratory data analysis, we are just trying to find patterns, not necessarily the whys. So this side is more of the churn. You see it slightly here, so there might be some small influence on the churn. So you see with one plot, we are just able to look at all these continuous features easily, quickly. So we see here, we look at, okay, total day chart also seems to have some slight small thing here, but not too much though. But then really showing that maybe the churn is really pretty difficult to predict clearly, but then we would be moving ahead and iterating to see how we can improve our machine learning models. So you see total number of international calls, the proportion changes. So there are some that are really less, there are some that have a high proportion of churn, and then we also have the international charge. So that's okay. Now let us look briefly at the outliers to see how it looks like. So then again, we want to exploit this sns.boxplot. Then we do the same thing up here. So you see it's just the same code that now, but what we are plotting at the end is boxplot. So matplotlib and SNS are collaborating to give us this very good loop. So if you see here, this is positively skewed because the outliers are on the right. You see here also is positively skewed because there there's just a slight outlier there. Then you see there are many outliers to the left and to the right on total day minutes. So we are trying to see that, so we notice here that there are really so many outliers, and this might hinder our linear learner model. But then let us see how it goes. Remember, this is an iterative process. You can always go and come back. At the same time, we want to learn the process and with examples. So if this is positively skewed for the total international calls, international charge, it is skewed. There's the outliers to the left, outliers to the right, because this is the first quarter and the third quarter. The quarter range is here, so we have lots of values here, lots of values there. Good. So we are using our statistics, and then we are also trying to understand, just see how our data looks like, so that in future engineering phase we'll be doing some changes. And then it's iterative. You can always come back and improve and improve and improve and get better. So there's a lot ahead. Let's move on. So categorical variables, these are your categorical variables that you want to observe. So you have your state here, your international plan, voicemail. So we can always, let me run that. So we could always come out and say there are 51 states, there are 2 categories for international plan, voicemail, and there are 2 categories. So that we can always get that. And then now let's come here. So we do the same thing again. Remember, we love this SNS.count plot. So we do the same thing. We have our subset of variables. We pass it here. So we look at this. We say, okay, international plan also seems to have something maybe interesting. Look at this one is not imbalance, unbalance, imbalance here. But then for the no, so those guys, people who are on international plan, they have a high tendency to churn. So we need to, again, we might not know why yet because the data set doesn't tell us why. But data science is about finding patterns and exploiting them, not finding out why things happen. That is more, leave that to the statisticians to do a good experimental design and tell us why things happen. But then we are on first on the what is the relationship and how can we exploit it to improve. So we also see here proportions are different. So that's it. So we could also look at some correlation metrics, try to plot some to see what are possibly correlated, and we find some interesting things here. Normally, this diagonal is what should have 1 normally, but now when we start seeing 1 like this, for example, on the total day charge, and then if we go up here, it is showing that if we get 1, 2, 3, 4, so 1, 2, 3, 4, so total day charge and total day minutes. So we see that there is a strong positive correlation here, and this is going to affect our model, because it is showing that which if we understand the telecom, it means that one column is this is how many minutes I spent on the call, and then how much I was charged. So this would always be directly proportionate. As the more I spend, the more I'm charged. So we might need to drop, say, minutes or drop charge, so that we don't have this multicollinearity, which is going to greatly affect our model, especially if we are using a linear model, for example. So we need to be careful. So again, we see another one here: total day minutes, so total evening charge, total night charge, total international charge. So we seem to get the same pattern just by this simple visual here, line of code here. So it is showing us that we will need to choose between keeping total day charge and total day minutes. We have to sacrifice one of them. Total day minutes, total evening minutes, and total evening charge. One of them has to be sacrificed. Total night charge and total night charge, yes, and total night minutes is the same pattern here. So we've seen that pattern, and total international charge and total international minutes. So one of them has to give way. Okay, so you could see it down here, for example, here, total international charge and total international minutes. So we need to one of these have to give way, so that we don't have that multi-collinearity. So which we discovered because of our exploratory data analysis. So that's good. Let's move on then. So if we inspect the variables directly, we can put the total day, the charge, and everything concerning the day, its minutes, its calls, and its charge. And then we see here that again, which confirms the fact that we have total day minutes and total day charge correlated, strongly correlated. So one has to go pretty perfectly correlated. So one has to leave, and then also here we can look at this. So we are looking at total day minutes. We want to plot and see how it affects the churn. So it seems to be having something interesting. So we will probably need to keep this total day minutes, and then maybe total day charge can go off. So now we come here, we look at the total day calls. So we see that it's not really maybe like popping like this one. So we might this one might really be what would be left behind. So just we're exploring and then SNS pair plot. So we want to also do this for the evening minutes. So we are trying to see here again we have the same correlation, which is saying that our total evening minutes and our total evening charge are strongly correlated. So we want to see again um, who looks better. Total evening minutes. Okay, this is how the true looks like under there, and then total evening calls is how the true looks like. So we would see the up here the correlation is slight, some slight, some slight, some things, but then here it's not really there. So it's not really like that popping out like the other one. Same thing for night minutes and calls and charge. We are going to plot this to see the correlation between them, and then we also try to see who looks a bit interesting. So this one is not really looking that interesting, nothing really peculiar. There's one too, really nothing that's peculiar, so we could just choose one of them. And then we also have the international minutes, same thing. Remember guys, we are doing exploratory data analysis. Want to be one of the data, so we have a strong positive correlation again here, and then we try to see okay, maybe a slight something here, slightly, and then we also try to see here. So now we are looking at the international call. So maybe some small things are happening here. So that is good. We have done our exploratory data analysis. So we've just checked a view. We didn't change anything. We just looked through the data, and then we are like taking mental notes and also developing a strategy. And here we could decide to say maybe this data looks kind of weird. We need to get new data because maybe of one or two things we've seen here, or we need to change the model maybe because of the outliers we've seen or things like that. So but then let's keep moving on our journey. We are trying to understand the end-to-end process first, and then the details and the iterations second. We'll always come back and iterate and iterate and iterate until we get very great results. So let's move on now to the Telecom Churn feature engineering sheet. So here we start changing things. We start changing things here. So I'm going to change this to default Python. Select it. Now we are now on the feature engineering. So we import our libraries as usual. We do now the train test split so that we keep the test data set and the train data set. Normally we could have had a validation data set and only keep the test data set aside. The model will never see it till the end, but no problem. Let's go. We just did the train test split for simplicity. So the train set and the test set. So let's keep moving, and then we'll also look at the missing values because I'm also trying to give you the framework. We did it in part 1 in more details, hands-on. So now we are trying to also solidify it and see that this is the process so that you master the process and you're able to apply it anywhere in any project. So we look at the libraries, we do the train test split so that things don't spill in, information don't spill between train and test. Remember, if you're doing a Kaggle competition, you will not split early. You're trying to steal some information from the test to the train. So you wait, you try to get steal information. But since we want to build a machine learning project to help our company move forward, we don't want to cheat. So let's split early, and then we hide the test, let it not influence us. We do it as if we don't know the test exists, then later we can come back to it. So missing values, then we can look at some the temporal values, and then categorical variables, the rare categories, and then we try to standardize the variables. So then import numpy, this, we know them already. We've done that before. Same thing. We bring in the data, same thing. So let me run this. bring in the data again, same data, but now we are not doing again the data.copy. So we are on the data set itself directly. So anything we change is permanent. So we do the train test split. So we call our friend scikit-learn to bring us the model selection and the train test split. So when we do that, we are going to separate the data and drop the churn so that the X is only having everything except the dependent variable, while the Y is just the dependent variable. So let me run that. Let me run it. Let me run it. Then now this is actually the split. So we are saying from sklearn model selection. Okay, we've already imported it though. No problem. This line is not necessary again. So we are doing X train, X test, Y train, Y test. So we want to split the X, for example, into X train and Y train, and then we split also the Y into we want to split the X into X train, sorry, and X test, and then we split the Y into Y train and Y test. And then we are using a stratified split because we notice that it is an unbalanced data set. So be very careful here so that we should be able to split them in stratified sampling. So if you remember your statistics, stratified sampling, it's not the random sample here because of that imbalanced nature, so that we can try to capture kind of like relatively equal proportions of the true people actually churn in both the test and the training set. So we also set the random state to 42. It could be 0, it could be anything, and then we are taking 20% as test, 80% as train. So remember, we could split it to validation set, training set, and test set 3. So but then let's just move on. So let's do that split. Now when we do that, now we say data set dot is any. So we wanted to look at the missing values again. Remember, we already know our results. We are just showing you the process. There is no missing value. Thank God. That's great. So now we are now looking at for now, let's leave it out. Let's move on. So we move on with that. So we're going to look at categorical variable treatment. So our categorical features. So we are like saying, okay, for this feature in our X train. So I think here, okay, I made some updates. So normally we are to get back our training set together so that we can be able to use it to use both the Y, to use both the X train and the Y train together so that we can do our modeling easily. So for example, what I'm saying here is, let me come here. So let me come here, and then we say, okay, this is our train test split. Let's run this. So we put that here. So we could decide to say, okay, let's just run the code here. So pd dot concat. Now what are we concatenating? We are concatenating the X train and the Y train. Let's do that. Then now what are we saying now? We are saying the axis equals to 1. So let's do that. Let's run that. So now when you look at it, you see that even though we had 3,303, we've split our train and test set here. Let me just show you here. Let me go back here to Bora. Let me go here. So our X train is how many? 2066. Our Y train is 2066. That's what we just joined down there. Then our X test, because of the 20% split, is just 667. Then our Y test is 667. So I'm trying to fuse this X train with this Y train after this split, so that we have one bulk data set called train set, which we'll take to use the next phase to deploy, but we can also separate the columns there or in Sagemaker. Then I'm trying to fuse also this X test to this Y test so that they form the test set, so that these ones now will be used later to also build the test set. And remember, all the feature engineering that we are doing on this training set, you should also do them on the test set later on before deploying the model. So let's do that together. So this is what I'm doing here. I'm saying, okay, let me call this now the new train set. So train set equal to this. So that is the train set. So now let me check the train set. Let's check the train set. This is it. So we have the 266 and the 20 columns. So which means that it successfully fused the two, this X train and the Y train. Now let's move on then. Let's do same for the test set. So I'm going to do same for test set. Let's go back, go here, add, go to test set equal to, I'll just copy this, change them to the same so that we don't waste time. Remember, we don't want to waste too much time. You can always look at this later. So I'm just going to change this to X test, and then I'm going to change this to Y test also. So let us, when we run that, then we click here, we go to test set and run it. So again, you see test set the 6, 6, 7 and 20 columns now. So it is also added back the for churn thing. So it's just to keep them together. And then while we go on, so everything we are doing on the train set, we'll do it on the test set. So let's move on then. So I think you got it there. So here now, let's put our train set here. Train set. So we check, nothing is there. Good. We knew already that there are no missing values. So we are going to update this because I prefer that we should just fuse them and export them as two CSV files. So we are going to change this now and use the train set instead. Train set. And then we're also going to use the train set here. So everywhere there was X train, we use train set. I prefer it like that. Second thought. So remember, I told you it's an iterative process. So if we want to print these categorical features, we have this state, international plan, voicemail plan. Good. So let us go again here. We change this to train set. Remember, it's our it's good when we do live sessions like this. You see some of the things that we do at the back. So these are the different states that we have. So now, since there are many, so we are trying to say, okay, let us look at I could also use this to be able to separate the rare categories and also the categories that are like you know, let's say they are greater than maybe 2.2%. This is something that you can also do. It's really a lot. So but then let's move on then. So if we want to check, we can say, okay, there's the international plan is having no and yes. The voicemail plan is having yes and no. That's okay. That's okay. So we did a lot in part 1, lots of detail. So we will not bother to go into that. Already from part 1, you should have already had some basics. So let's move on then now. So now what we're trying to do now is we're trying to do our label encoding. So remember, all of these we have to change them again to train set. It's still the same thing. Train set. Train set. Good that you're seeing how we're doing these things live, so that you see how it works. So train set, still the same thing. Now we are trying to get our label encoder from sklearn, because we want to be able to encode these labels so that we have them, instead of these yes and no's, we have them to be in ones and zeros, because our machine learning model will want digits. So that is why we are doing that here. So we are calling on the preprocessing import label encoder. We are instantiating that as LE. Then we are fitting it, transforming at the same time this object to say change now again. Let's put our train set here again. Say our train set voicemail should be transformed to this train set fitted with 1 and 0. Our train set international plan should be transformed to this other train set fitted. Good. So let's run it. So now let me go back. Let me run this one. Then I run that one. So it's okay now. We can go and look at our train set here. Train set. And we remove this one here. Remember now we fused them. So we can look at our train set. So where we had our voicemail international plan, see voicemail now is 101. So also international plan is 00. So before it used to be yes and no, like we saw here, yes and no. So it used to be let's see if we can get it here. It used to be yes and no, yes and no. So this one, our machine learning model will not understand the yes and no. That's why we are changing it to figures so that it can understand. And then now we can also do now some feature scaling so that we make it easier for the model to calculate and to run. So since we have some variables that the ranges are wide, let's say this one is 200 and something, this one is 30. So we try to just standardize everything here with the by saying for remember when you're doing like a decision tree or the XGBoost, you might not need this. It's not too necessary. But with linear models, like you need to do some scaling so that they can be able to, so that some don't weigh have a higher coefficient because they are higher in value than maybe the smaller ones here. So that's very important. Try to look at review your basics. So feature scale. Now we are avoiding the state, the area code, the account length, all the categorical guys, and then we are feature scaling the rest. So let's go here. We want to feature scale this the feature scale set, which consists of all features except these ones. If feature not in the state and that. So when we come down here now, we run that. So here again, let us concatenate. Let us create now. Let us do that. Let me do our train set. Let me correct the train set. Then I correct again the train set here. Train set. So again, we are trying to concatenate this state, area, length, that the things that we had removed. And then of course we have to reset index. And then now we now say add that now to this, create a new data frame with this scalar dot fit. So transform with the scalar dot transform now the whole thing, the whole train set subset with the feature scale, the ones that are non-categorical, and then the columns is also equal to feature scale and the axis is 1. So we are doing it at the level of the column. So when we run that, we get that. And then now if I come here and I run the train set, remember doing this every week plus have full-time employment and other projects. It's not easy, but then we want to make sure that you learn. So I'll do my best to make sure that you have the best that you can. So train set head, this is what we get here. So we have this, looks interesting. So now what we could do, let's just come here. We could remove now these ones, this state, this ones here. So let me just see if we already have a list here. So let me just come here, state, area, international plan. Anyway, voicemail plan is good to be there. So I'll just edit it down there. Let me copy this, bring it down here. So I'm going to say let's say train set dot drop. Now we can I want to paste what I copied. So we know that, okay, state, yes, state is going to be out, account length, area code, yes. So now international plan, no, we don't want it out. We just removed it last time because it was already ones and zeros, so there was no need to standardize it again. voicemail plan, no, you're not going out. So we just did that. So then now we have the customer service calls. So also you're not going out, we are not dropping you, you have a role to play. So this is like the list we want to drop. So now we can say that, okay, we want to drop this from the columns. So we can say axis equals to 1. So when we run that, if you see now, the train set starts from here. So there's no state, there's no account length, there's no area code. So our data set starts from here right up till the end, which is interesting, which is what we want. So then now we can now go here. So we can say our we drop that, and then now we can also now say either in place equals to true, or we reset train set equals to that. So we have two options. Either we do that and then we say in place equals to true. So let's just use in place equals to true here. In place equals to true, and run it. So now let's run the train. Let's try the train set, and then we see, okay, so it's fine. It has been done like that. So we can do that, and then now it looks good. So let us now export this to a CSV file so that we can be able to use it now to do our machine learning in the subsequent editions. So we are going to say train set. So if we want to export to CSV file, export to CSV file. Yeah, so I'm going to clean this code, and then I'm going to put it up in the GitHub link, this video. So we are going to say train set dot to CSV. Then we can call it, let's just call it train clean, for example. Let's call it train clean dot CSV. Then now we also try to remove this index. Not interesting. We could have reset the index, but no problem. Let's do index equals to false. So let's run that. Watch here. So you see you have your train clean here, your CSV. So you see now that you have your international plan, your voicemail plan, your number. So everything looks cool, everything looks okay. So we are able to take it now to the next level, which is to use it now to do our deployment in the next week, and close this part 1B and move on to other more complex and higher things as we move through this our series. So it's interesting to see that we got to this. So don't forget, we have to come back to our test set. That's your assignment. Do the same thing for the test set so that we have the same categorical split, same thing we did here. Do the same feature scaling, do the same thing we did here. Filter out the columns, and then you also export as test clean.csv, because next week I'll do that, and then next week when we come, we'll just be deploying the model. So I hope you enjoyed this video today, and if you do, you can like, or you can also share with your friends, and then see you next week when we do the continue with this project and go on with the deployment. Thank you. I'm going to leave the link here, and you can go ahead and play with the code as you want. Thanks for watching. Have a nice day. Bye bye.